All right, everybody, now that we know our ions, now comes Judgment Day. All right, like I said, we reordered Chapter 6. This first part was all in the covalent part, and this part down here, we're going to do our ionic part. You need to know those ions to do ionic bonding, which is what we're going to do right now. All right, so our ionic bonds are going to encompass the 118 elements that we have put in some sort of metal, non-metal order, and we can make over 4 million compounds. So we need to be able to use an inventory in order to determine how much of each element we have. Okay, so an atomic inventory is just going to show, using those subscripts, how many of our elements are in our compound. Like if we have K2SO4, okay, the subscript comes after the symbol. That means we have 2 Ks. There is an implied 1 right here for the S. Every capital letter is a new element. So we have 1 S, 1 sulfur, and we have 4 oxygens. That one's pretty easy. When we start getting into our multiple polyatomic ions, that's where we're going to have to do a little bit of multiplication to figure out how many of each we have. Fe2SO4 taken 3 times means we have 2 irons. Then we have 3 SO4s. That's the same as saying SO4, SO4, and SO4 3 times. So if you count up your sulfurs, you have 3 sulfurs. This 3 gets distributed and multiplied by that 1. And then you have 4 times 3 oxygens, or 12 oxygens. That's where you would get 4 plus 4 plus 4, giving you 12 oxygens right here. So that's something that we're going to need to keep an eye of and track of. All right, so just to review for you before we get into our ionic bonding, know those ions. We're going to use them for the remainder of the course. Okay, from your common ion sheet, group 1 is going to be your 1+ cations, group 2 are your 2+. Everybody else is going to have some sort of Roman numeral, except for silver, zinc, and aluminum, which are on the diagonal. And you have your silver, and then you have your zinc, and then you have your aluminum. Okay, in your column 11, 12, and 13 with your 1+, 2+, 3+. And then your anions are going to have your halogens be a 1- in group 17. Group 16 will be a 2-, 15 will be a 3-, 14 will be a 4-. They want to get to be a noble gas. And then you obviously have to know your polyatomic ions. So those behave just like regular old elements. You have things like ammonium and sulfates, and don't forget your Nick the Crafty Camel. You're going to need to know those ions. Okay? So here we go. What we do in ionic bonding is we are going to bond, wait for it, the ions. Get it? Because it's ionic bonding. All right, so we are bonding a positive cation and a negative anion to make a neutral ionic compound. And we always write the positive first and the negative second, okay? So whatever the general formula is for your cation and whatever the general formula is for your anion, that positive and negative charge are going to attract. And when it attracts, it is going to make a neutral compound. There are no charges here whatsoever. So this is why it was so important to learn your ions and your charges, because they combine in different kinds of ratios. So if we go into the simplest one, the easiest one that you're going to get is going to be your sodium ion and your chloride. Okay, sodium is Na+, chloride is Cl-. If I put them together, the 1+ and the 1- are going to cancel out, and my formula will be NaCl. That is the formula for table salt. Okay, that 1 plus and 1 minus cancel each other out, and that is your formula unit for sodium chloride. Now, what if they don't cancel out? That's where we're going to have to do a little bit of thinking. If we have our calcium ion and chloride, calcium's in column 2, so it's a 2 plus. Chloride is a 1 minus. If I put them together, I get Ca plus Cl. That has a charge, so that doesn't cancel out. So what do? How do we solve this? Well, I have to make something neutral. So that means I kind of need to find a common multiple that they both fit in. What does 2 and 1 both fit into? That's right, they both fit into 2. So I'm going to need 2 Cl minuses to cancel out a 2 plus. So my formula will be CaCl2. Now, the property that we use for this can be used very similar to what we see in math class, where you kind of multiply to get your common multiple. All right, it is called the Criss-Cross Method. Criss-cross makes you want to bond. Love Criss-Cross. Oh man, I was in 5th grade when they came out in 1991. Ooh, I love it. So what you're doing is you're using your charges at the top of your ions to be the subscripts on the bottom. All right. So if you go back to that calcium, Ca2 plus and Cl minus, what I'm doing is I am going to take this 2 plus and I'm going to drag it down here, and this 1 minus, and I'm going to drag it here, and then my formula is going to be Ca1Cl2. But we don't write the 1, that's understood. So we write CaCl2. And that would be my formula. Okay, now there's one thing you need to star circle highlight. Sometimes you might have to reduce it to a lower ratio. I'm going to show you an example of that very shortly. Okay, so here we have iron oxide, iron 3 oxide, and we have iron 3, which is an Fe3 plus, and oxide, which is an O2 minus, and a 3 plus and a 2 minus don't cancel each other out. So what they have is a common multiple of 6. So this 3 travels down to here. This 2 travels down to here. So then I get a common neutral compound, Fe2O3. Okay? What you're essentially saying is I am going to need 2 3 pluses to cancel out 3 2 minuses. Okay? Because look what happens. A 3 plus and a 3 plus add up to a 6 plus total charge. And what do 3 2 minuses add up to? That is a 6 minus total charge. So what do these two things do? They cancel each other out. And when they cancel each other out, you get a neutral ionic formula. All right, that's the whole point, is to get rid of the charges. You have to combine the charges the right way. All right, so if you have a calcium ion, okay, Ca2 plus, and oxide, O2 minus, and we crisscross the 2 plus and the 2 minus, you get a 2 down here and a 2 down here. So be careful. If these charges are the same, they just cancel each other out. All formulas need to be the lowest ratio. So is a 2 to 2 ratio the lowest that we can get? No. We can reduce that down to a 1 to 1 ratio. So the Ca2O2 reduces down to a 1 to 1 ratio. So we get into the habit of crisscrossing a lot. So if you do see 2 of the same charges, whether it be a 2 plus, a 2 plus, a 3 plus, and a 3 minus, they just cancel each other out and you just need 1 of each. Okay? The other thing that you need to pay really close attention to is going to be your ionic compounds that contain a polyatomic ion. And this is why we need to know our ions and where the charges go and where the subscripts go and all that kind of stuff. All right, iron 3 ion is going to be Fe3+. Sulfate is SO4 2-. Make sure you criss-cross charges, okay, not subscripts. That is going to be the key. All right, leave that 4 alone. So you take this 3 down, you take this 2 down, and you say Fe, I'm going to need 2 of them, and SO4s, and if you have to in the beginning, draw a box around your SO4s so that you don't touch the formula for sulfate. I need 3 of them. And that's how you get them to be neutral. Okay, in the next video, we're going to show you a couple of examples to help you work through some of those pitfalls.